Hi, for question number 11, a curve has equation y is equal to kx minus 3 all to the power minus 1 plus kx minus 3, where k is a non-zero constant. Find the x coordinates of the stationary points in terms of k and determine the nature of each stationary point, justifying your answers. For the second part, this is the diagram which shows part of the curve for the case when k is equal to 1. Showing all necessary working, find the volume obtained when the region between the curve, the x-axis and the y-axis, and the line x is equal to 2, shown shaded in the diagram, is rotated 360 degrees about the x-axis. 5 plus 7 marks, that's going to be 12 marks. Okay, for the first part to this question, this is the equation of the curve. We need to differentiate this. So we're going to get dy by dx is equal to, if you differentiate this, you're going to get minus 1 times kx minus 3 to the power of minus 2, okay, and then plus k. Okay, so that's going to be then minus 1 over kx minus 3 to the square plus k, and times of course k, because the derivative of that, so times k. So we're looking at then k minus k over kx minus 3 to the square. I'm going to set this to 0 because we're looking at stationary points. Therefore k over kx minus 3 to the square is equal to k. That could be over 1. The k can cancel out, and we're left with kx minus 3 to the square is equal to 1. So that's going to be kx minus 3 is equal to plus or minus square root of 1. Kx is equal to 3 plus or minus 1, and therefore x is going to equal to 3 plus 1, which is 4, divided by k. That's the first value of x. The second value of x, 3 minus 1, is 2, and that's going to be 2 over k. Right, so this is the values, these are the values of k, and we need to determine the nature of each of these points. Therefore we're going to redifferentiate what we just found here. So we're going to now do d2y over dx square. Differentiating k, you're going to get 0. Differentiating this one, that's kind of so we've got then k into kx minus 3 to the power of minus 2. If you differentiate this, you're going to put minus 2 here, minus 1 there, and k times the derivative. That's going to be 2k square over kx minus 3 to the power of 3. Okay, so that's d2y over dx square. Now that's going to be then power 3. Okay, so that's cool. Now from here, what do? We're going to substitute the value of k, the value of x in here. So we're going to say then when x is equal to 4 over k, so d2y over dx square is going to be equal to 2k square divided by k times 4 over k is 4. K times 4 over k, that's going to give us 4. 4 minus 3 to the cube is 1. That's going to be equal to 2k square, and this is clearly greater than 0. So at that point, at k, at 4 over x is equal to 4 over k, we have a minimum point. Now we do the same for x is equal to 2 over k. So d2y over dx square is going to be equal to 2k to the square divided by, this time is going to be k times 2 over k, that's going to be equal to 2. So 2 minus 3 to the power of 3 is going to be equal to 2k to the square divided by minus 1, that's going to be minus 2k squared. It's a negative, and it's less than 0. Therefore at that point, I mean at x is equal to 2 over k, we have a maximum point. Now that's the first part to this question. Now for the second part, we need to find the volume generated when it is rotated around the x-axis 360 degrees. So the equation is y is equal to x minus 3 to the power of minus 1 plus x minus 3. Now to integrate this, but first of all, what's volume generated? Volume generated is equal to pi integral of y squared dx. We're going to square all of that, so y to the square is going to give us x minus 3 to the power minus 2 plus x minus 3 to the square. Therefore, the volume generated is going to be equal to pi and the integral of all of that. Okay, with respect to x, of course. Integrating this, pi, okay, so minus 2 plus 1 is minus 1, divide this by minus 1 is going to minus x minus 3 to the power minus 1, okay, plus here x minus 3 divided by 3, the new power is 3, and so this is integrated now. What we need to do is just put the limits as 2 and 0. Okay, so that's going to be equal to pi, and if you apply the limits, 2 minus 3 is minus 1 to the power of minus 1, plus 2 minus 3 is minus 1 again, so minus 1, that's going to be minus 1 over 3, I mean minus 1 to the cube, because if you integrate this, of course, this is the power is 3, okay, 3 here. Alright, so then minus the lower limit, and the lower limit is going to be equal to 0 minus 3, and that's going to be minus here. 0 minus 3 is minus 3. I've got then minus 3 to the power of minus 1 plus, in brackets I've got 0 minus 3 again, so that's going to be minus 3 to the cube minus 3 to the cube over 3. So I've got then pi, if we do all of that, this is going to be equal to minus 1 times 1 is 1, 1 minus 1/3 over here, and then minus, this is going to be equal to 1 over 3, minus 1 over 3 times minus 1 is 1 over 3, and then of course this one is minus 27 divided by 3, which is then minus 9, plus minus becomes minus in a way. So if you do that on your calculator, you will see that this is going to be equal to 28 over 3. Therefore, the volume generated is equal to 28 over 3, rather, pi units cube. So this is the second part of the question. Okay, so take care.